I'm here from Bay Area land, and I'm here to give you a magical mystery tour of what it was like to build Pinterest in those first couple of crazy years, which made me all bald and kind of crazy. So I'm going to take you on a tour of our evolution, starting in March 2010 when we launched, and going to about a year ago when it was no longer a startup. And we knew it wasn't a startup anymore because we had a PA and a finance group. So if you go back to March 2010, we launched the site, and nobody cared. At the time, it kind of looked like it does today, but very simplistic. And we were on Rackspace initially. We were one of the first groups to start playing with the cloud. It was kind of weird, but let's try it out. And we had one web engine and a MySQL database and an engineer and two founders with a crazy idea. And at those times, you keep everything simple because you want your founders and the people who are coming up with a vision to be able to make whatever they want. You don't have to worry about optimizing. You don't have to worry about layers and layers of abstraction, so you keep it simple. And that's what we did. And then nothing happened. Oh, let me tell you about our founders here. We had Ben, Paul, and the guy on the right is Yash. That was our whole team. So fast forward to January 2011. For the last 9 months, we were in what our founder called, we were in stealth mode, but not because we wanted to be. So not much change in terms of engineering because nobody was using the site. Hold on, there it goes. We did evolve a little bit. We started wanting to send emails, so you start having systems like task queuing and processing, all of that. We had MongoDB because everybody wants to have MongoDB. And we used that for counters, and we had MySQL, and we actually had a read slave, just in case the site goes down. Weird. And at that time, this was at our international headquarters. It was the founder's apartment. We worked out in the main room, and one of the bedrooms was our international boardroom, and the other bedroom was a bedroom. So this is us having international headquarter pizza. So we did start to suddenly see a bunch of growth. And from January 2011 to roughly September, we finally hit it. And every month we were growing, we were doubling every month and a half. So that meant every week we were growing by about 10 to 12%, which is a nightmare. Because every day something else is breaking. And we only had 2 engineers. Eventually we hired a 3rd engineer. But I just remember days sitting on a paddle boat with my 2 kids and my laptop. It's just the kind of world you have to live in. So at that time, we did actually, everything started to heat up. Everything was breaking. We went from one MySQL box to multiple. And the first thing you start to do is you say, well, I'm going to take this table of pins, and I'm going to put it on this MySQL box so I have a little bit more room. But you only have so many functions. We call that functionally sharding. And eventually, you're going to run out of functions. You have pins and followers and other things. And so we had 5. 5 was about the max we could do. So we were kind of up against the fence, and it was breaking. And each one of those had a read slave. And read slaves are a dangerous, bad, terrible, terrible thing. We use them for backup now, but as read slaves, you make all sorts of bugs because it takes a second. So you put your data in, and you read it, and you put it in your cache. If you read it from the wrong spot, you'll put the old data in the cache, and it's a hassle. So the moment you're using read slaves, and you need them for load balancing, it's time to start thinking about next plans. We also, because of the way these things work, that was on fire, and all these people came to us and said, we'll solve your problems. So Cassandra guys came by, and MBase guys came by, and the Mongo guys came by again, and Elasticsearch and several others, and they said, yeah, just add a box. What could go wrong? I said, gee, we don't need engineers. This is so good. Only every one of those technologies nearly failed on us, and I'll talk a little bit more about that. So first lesson we learned, it will fail. Keep it simple. Especially as a startup, you don't have someone to dedicate to your database. You don't have somebody to be the HBase or the MongoDB master when the thing breaks. You are the nuclear submarine technician. You need to know how to cook and how to launch the missiles. So keep it simple, especially in those early days. Next thing, if you're the biggest user of a technology, your challenges will be massively increased because you're the first one stepping on the next landmines. Nobody has stepped on them and fixed them. So that influenced us a lot and drove us away from certain technologies. Like Facebook uses MySQL. Okay, MySQL's good. So here we are. We moved into Palo Alto, California, and this is when maybe we're about 10 people, maybe 11. We had gone on a big mission to redo everything because everything was hot and breaking, and we used those lessons we had learned to simplify everything. And we ended up with this. We now have 10 MySQL databases sharded by IDs, and I have a whole talk on this if you guys are interested. I'll give you the link. And we decided to get rid of Memcache, MBase and Cassandra and all these others and focus on things that we know that work. MySQL works, Memcache, and Redis worked. So we dropped everything else. And then we sharded all of those, and then it actually survived. We were able to survive that pretty substantial growth period. And at that point, we finally actually had 12 engineers. So we actually had a person on operations, which was awesome. And we had people actually building a mobile app, and it started to separate a little bit. And then we also had some non-engineers. You started getting your finance in order and a lawyer and other things because you're starting to build more products. What'd I say? So then we had to knock down a wall because we were getting too big. So we took over the next space next to us. Lots of growth. The great thing is our sharding worked. The way you know your system works, the way you know you've made a scalable system is that you can throw money at the problem, and not exponential money, like a little bit of money. Normally, if your system doesn't scale and you throw more boxes at it, you actually make it worse often because the connections blow something out, or now you're putting more pressure on systems that already can't handle it. And so our system worked pretty well. We were able to add more MySQL databases and more Redis and more Memcache whenever we needed. The finance guys loved us. So we had, at that point, we started really ballooning, 65 engineers, and around 100 employees, you hit a spot that it's a tough spot in the company. I've been talking about scaling technology, but this is scaling your culture. You suddenly have to worry about, am I going to have management? Am I going to have, what kind of culture do I have? Do I have to worry about losing that culture? And I've heard people apologize to us, like I'm sorry you're going through that stage. It's a tough stage, something to anticipate when you get there. You need to work on making sure everybody's happy through that transition. A few more things. We actually brought in HBase, which is not simple, but we had enough people to dedicate to it, and it solved some of the problems we needed. And then the other thing is, for logging, we use a system called Kafka from LinkedIn. We tried Flume and Scribe and others, but Kafka worked, and we still use it today. Too many animations. Engineers broken down now. We actually had teams, and this came out of the necessity that you have to have a lot of communication, and you have to have a lot of good, strong teams that can communicate with each other. One of our big focuses in the company is really strong communication and feedback, and that gets even more intense when you get bigger. So we started to separate. We had a data infrastructure and science group, search and discovery. We actually made, for a long time, it was half of me was search. Thankfully, we actually got a search and discovery team. We started having spam and abuse as a problem, business and platform groups, a web group, a mobile group, and a growth group, and we had a separate infrastructure and operations group, and a lot of non-engineers as well to support everything. So the team, we moved up to San Francisco. We ran out of room in Palo Alto. If any of you guys work for Palantir, I've got a bone to pick with you, but that's a different story. So we moved to San Francisco. There's room up there. The team got bigger, and then the team continued to get bigger and bigger and bigger and bigger. Really awesome group. Lots of work going on. So I'd like to talk a little bit about the technologies. I hate it when you come away with a talk with a lot of great vision ideas, but nobody's told you anything you can use now, so I try to touch on that. This is our stack. I hope it shows up. There's a lot of bits here, but I'll kind of give you the layers. The very top layer, we're all on Amazon. The very top layer is our outer load balancer. We use Amazon's ELB. And then we send it down to a varnish layer, which is actually run by our systems. And we have two layers because ELB supports some things we need with load balancing, and Varnish supports some of the others. So Varnish, if you're not familiar with it, it's a load balancer like Nginx and HAProxy, and I highly recommend it. I think it solved a lot of the problems that Nginx and HAProxy were making for us. And after that, we actually get down to business. We have our API and our web apps, which do all the coordination and figure out what you want to see, and they also can spawn off projects over to the task processing system. And then we have a service layer. The purpose of a service layer is something you'll get into as your company gets larger, but you want to have a service to teams so those teams can handle it. So, for instance, with spam, you're going to start to grow this monolithic code base, and to deploy to it is going to take longer and more headaches. So if you could pull that piece out, hand it over to the spam team, and they're responsible for it, they can do all sorts of complicated things. You don't have to worry about other people breaking it, and I can deploy now in 20 seconds rather than hours. So we're starting to make services more and more. Different companies do different things. Facebook has one giant service and a few others, and they say it's a hassle to deploy. Amazon's got 300 every time you make one request, so that's another hassle. So we're trying to go through the meaty middle. And then finally, we have our data is at the bottom layer, and that's our images are stored in S3, and we front them with CDNs, and we have MySQL, Memcache, Redis, and HBase. And then also very important is that's our whole production pipeline, but everything you do on the site is producing data, and I want to collect all that data before it gets lost to the ether. And that's a very hard pipeline. We have a whole team dedicated to this called the data infra team. So everything that happens on the site pumps through Kafka, and we log everything. We log every single GET with lots of data. We log every event, which means someone changed some state, like an update or a create. And we log lots of little tiny things like signups with more info. The request log knows all, but it's also very unwieldy to deal with. So if you need something, you really need it, you can go to it. The event log is a little bit easier to deal with than we typically deal with that layer. And then if you really want to also log some other things that are more detailed to your application, you can do that as well. And Kafka worked for us. Flume and Scribe eventually died. It couldn't handle it, but Kafka's working well. And then out of Kafka's like a giant fire hose. You can watch the fire hose. So we have a system called Secor that takes in all the stuff from the fire hose, chops it, and puts it into S3. And once you're in S3, you're home free. S3 gives you really good durability, 11 nines of durability, and then you can do MapReduce and all the other things. But you got to get it you got to get it from your apps to S3, and that area makes you sweat. The other thing we do now with Kafka is we send all that data live to a system called Stingray, which we can then use for spam processing. We can watch everything that happens on the site and make new determinations within seconds. So if you're interested in how we did our MySQL sharding, actually the easiest way would be able to just search for Pinterest and sharding, but we have the talk up on InfoQ. And that we go into how we split up MySQL and how we built our sharding mechanism, which was its own big hassle, but I think it came out well. Okay, holding on here. Next big question. When we were sharding, we had this big question of what should we use? Should we go use Cassandra? Will that survive? Or should we go with MySQL, other things? We had to ask these questions. And so we came up with a list. And this is the kind of list I ask about anybody when they're choosing a new technology. These are the things you need to answer. First one, does it meet your needs? MySQL does a lot of different kinds of storage. It will act as a key value. It'll do relational. But it won't do things like O of 1 inserts. It's not really great for fast inserts. So if you need that, you may not want to go with MySQL. And MySQL doesn't help you with geography or complicated searches. But what MySQL does do, which is the next question, is how mature is it? Maturity, to me, is the blood and sweat divided by the complexity. And MySQL has been around since '94. It's been bashed on hard. It's used by Facebook. It's used by all these different companies. And it's got a lot of blood and sweat in it. And the complexity is not all that great. When we talk about complexity getting large, we're talking about these products like Cassandra, which is a magic sea of nodes that all have to cross-communicate. And that's a very hard problem. It's still a problem that sits in academia, and you're putting your data on it. Kind of scary. That's the next question. Next one, is it commonly used? And the reason why this is important is, can you hire people for it? In San Francisco, and maybe it's because it's San Francisco, I can walk out on the street and say, does anybody use MySQL? If someone faints in a theater, I say, is there a MySQL expert? Someone will raise their hands. But if you go and ask Cassandra, it's hard. HBase, we have not been able to hire. We've had to build up generalists into HBase in our company. Next important thing about that is if it's 2 a.m., can you get your question answered? With MySQL, yes. You can go and search any problem with MySQL, and I never found a problem that I couldn't find a Stack Overflow answer to. And the way to know it's actually mature is to go onto Stack Overflow with your question, and they will give you the answer, and then they'll call you a noob. So that's how you know for sure you found a mature product. How robust is it to failure? This is something that comes with maturity. MySQL has never lost our data. Somehow, someone has written a tool to take any situation, the hard drive failing anything, and we've been able to get the data out even in the most dire systems. Other systems, that was not so lucky, especially the newer systems, because nobody has treaded these waters yet, so no one's written the crazy tools. How well does it scale? This is a big question. Like MySQL does not scale out of the box. You have to write your own systems. So maybe that's where you need something like Cassandra unless you layer something on top of MySQL. Does it have good debugging tools is also important. MySQL has any kind of debugging tool you ever need, profiling, all these other things, and others are not so lucky. And is the cost justified? Well, these are all free, but you may have to ask this question if you want to go with Oracle. We didn't go with Oracle because we couldn't handle the cost. We had angel investors who knew MySQL existed, so that we can't use the big ones. So why Amazon? This question is becoming a little less relevant now that the cloud's kind of ubiquitous. But one of the reasons I do like Amazon is it has a variety of services. If you're not familiar with what they offer, you can get your own Linux, but you can also get all sorts of supporting things. So if you don't want to build your own database, you can go use RDS or Dynamo or whatever else they use. If you don't want to do MapReduce on your own, go get EMR. They supply all these great tools to just jumpstart whatever you're working on. They also have very good reliability, a very active dev community, and also they're not cheap, but they're really good at getting you boxes ready in seconds. And this is what really made Pinterest survive a lot of problems. If I need a cache box, it's weird if I can't have it in minutes. And this may not be as relevant as it was 2 years ago when people were still asking the data center question, but with the cloud, that's what's really transformed how we work. It used to be, people would talk to me about the data center, it's going to take me 6 weeks to get that box. So you have to either plan ahead or just suffer. So the cloud's really changed how everybody thinks about building sites. There it goes. I talked about this a little bit. We use Route 53 for DNS still. We use ELB for that top layer load balancing. It works really well. We use Ubuntu image for our EC2 instances for most things, Varnish, and for our data and our caching and our web layer and all of our services. And then we use S3 for our images and all of our logs. And the other thing, we are a Python shop mostly. I like Python. It's extremely mature. I don't think we've run into many Python bugs. Everybody knows how to program Python. This also goes true fairly for Ruby. A lot of people know how to use Ruby, and it works well. The community is really, really good. One of the best. There's libraries for everything. And you can prototype something very fast. I've existed in the Java world, and the Java world is good. It's just Python somehow lets me go a little faster. And also Python has just enough framework so that you don't get lost in a sea of code like I think some languages like Perl and PHP can do. And it's open source. I think this points to, this is kind of true for most languages, but I put it up there for symmetry. Free is a good thing. Where Python starts to break down is Python is not fast. It is an interpreted language, and it has a garbage collector that I read the source code for it. It's 1 page long. I worked in the Java world. The Java garbage collector is massive. And while that's not a perfect measure, it is pretty close to the point that the Python garbage collector is so simple, it just stops everything, and nobody cares. So the problem with that is as you want to start pushing your latency down and your variance really short, you can't use Python. So we've had to start using Java, and Go looks promising. If you haven't used Go, I'd go look at it. It's from Google. It's sort of Python and Ruby-like language with a mix of a few other things, but it's still in the scripting territory, and it is fast. It needs to be faster, but it's fast. We also we use Python for everything. I guess this is a repeat. This is about all the usage. Java we're now using for Varnish plugins. We use it for our search indexers because they need to be really blazing fast and have lots of threads. And then some of our high frequency services like MySQL. We want to push down that variance quite a bit. So then big question, why MySQL and Memcache? Why not all those other systems we used? And this is my recommendation to all of you to consider. I think MongoDB is growing, but anytime someone comes to me and says, I want to use MongoDB, I make sure I ask them why. Because if your reasons why match MySQL, MySQL is far more mature and a really solid system. And Mongo is improving quickly, but I think you need to consider the trade-offs. MySQL is extremely mature, and so is Memcache. And Memcache has been around for about 12 years now, and the thing is really simple. And that combination made it mature fast. It's also used by a lot of people. There's very rarely catastrophic loss of data. I've lost data on Mongo, Cassandra, Elasticsearch, and MBase. All have gone down catastrophically, pulling my data out with them. Their response time for MySQL is really predictable, which is important. Other ones, your response time can go from a good 10 milliseconds to multiple seconds pretty fast within a couple hours, but MySQL always seems to go nice and linearly until that last drop and you can't handle it anymore. There's also very good support for these tools. If you haven't used MatKit, I'd recommend getting it. MatKit, M-A-A-T-K-I-T for MySQL will profile everything in MySQL, and it points you really quickly to your bad queries. You can also use all these different backup mechanisms with MySQL. There's Inno Backup, which can do online backups, and there's also extra backup for even better online backups. And the community is really good for MySQL and Memcache. So if you're building a system, I would still recommend going with MySQL and Memcache and take out all of the hassle of all these other crazy newer tech until you get a little bit bigger and realize what you really need them for and can hire someone dedicated to those tech. So we use MySQL and Memcache for all of our main storage. So users and pins and comments, we put them into MySQL as a blob, and then we front that with Memcache. It's not as necessary as it used to be these days with SSDs, but we still do that because Memcache is a little bit faster, a little bit easier to maintain, because you can just add more boxes easily. MySQL is a little more complicated to add more boxes. So Redis. Redis is a newcomer, but we love it. If you haven't used Redis, I recommend playing with it. It's a key value store like a hash table, only it has actual lists and sets and sorted sets and all these great things to help you prototype quickly. And it also works really well. We used it for our feeds for a long time, where if I have 80 million followers and I post one pin, I've got to put out a pin ID on 80 million followers. And Redis could handle the push really fast. MySQL can't handle that because it's a tree internally and it's a little slow. But Redis could. It also has different kinds of persistence, which is really nice. MySQL saves all the time, really fast, 1 second. And Redis supports that. Memcache never saves, and Redis also supports that. But it also has something called snapshotting, which is great on the cloud. Because on the cloud, your neighbor may decide today to start running a Fibonacci sequence just to screw with everybody. And that will slow you down, especially if they start pounding your hard drive. But with snapshotting, Redis will save all of its RAM down to the hard drive every once in a while. And that's, if you can skip every once in a while and save only in those times, you can save a lot of I/O pain. So that weathers a lot of problems. Now, the downside is that if you save every 3 hours, you might lose 3 hours worth of data. So for things like home feeds, that's okay because home feeds constantly have new data coming in. This is your feed that you watch, like on Twitter or Facebook. It's your wall. So if one box goes down, then we'll pull that up from backup, and then some people might go back in time a couple hours, but pretty fast it'll fill up again. And the nice thing is it simplifies everything if you don't have to have a lot of backups and a lot of everything. And especially if you don't have to worry about latency spikes because your neighbor's going nuts. We use Redis for our whole follower configuration, meaning like all the relationships, I follow you and that person follows my boards and all those little complicated things. We use Redis for that. We use it for storing configurations. For a long time, we used it for our home feeds. We don't use it anymore. I'll explain in a moment why. And we also use it for public feeds. And then we also use it for caching. So HBase. HBase we brought in. I was the one who was dragging, kicking, and screaming against it, but in retrospect, it did some really good things. We did it once we had enough engineers to support it, and it's also a very good product. It's not used that much, but by many companies, but by the companies it is used, they're passionate about it. Facebook uses it. We use it. It's very difficult to hire for, but you do get actual fast insertion times, which you don't get with MySQL. The insertion times on this are actual O of 1 insertion times, so you can pummel that thing. So home feeds are now in HBase for us. The reason we took them out of Redis is Redis has to sit in RAM, and if we wanted to quadruple the size of everybody's home feeds or make them infinitely long, we couldn't do that. So we put them in HBase where the chunk that's relevant will sit in RAM, and the rest will funnel out to the hard drive. It also has really good integration with Hadoop, which is nice. You can put data in there, and you can reference it from your MapReduce jobs pretty easily. The performance is seeming really good so far. Facebook uses it, so that means they've already treaded the bad news before us. And in general, it's been working well. You have your scary times, but we have dedicated people to it who really understand it well and are making it work well. So we use this now for our user feeds, the home feeds. We store rich pin data in there. That means we go download websites from, we look at websites that have rich pin information, and we'll take them and we'll put them into HBase. We also now put our spam features in there because it's a really convenient storage for putting lots of little tiny bits of data. And we also store user relationships back to pins in here a little bit now. So big question people ask me, so I thought I'd answer it now. What happened to Cassandra, Mongo, Elasticsearch, and MBase? I sort of went through this, but I thought I'd take one of the examples and walk through it a little bit. I'll take MBase. MBase is a memcache. It looks like memcache, but it actually stores your data down. It magically clusters everything. And if you're familiar with something like Paxos, and if you're not, I'll give you some sleepy time reading afterward. But Paxos is an algorithm for coming up with consensus among a bunch of nodes. And that's what a lot of these systems use to make sure that if I put up the letter A into one box, it's replicated to another box, and it tells me when that's done. The problem is that's very complicated and hard to get right, and that's the way most of these systems go down. And that's what happened with MBase. So we use MBase for storing counters, so it met that first question. It meets our needs. It's not very mature. So the problems we ran into of that is at 3 a.m., I remember it broke. There was nobody online with any answers and nothing I could do. So from 3 a.m. to 6 a.m., I converted the system all the way to MySQL and Memcache to support whatever I needed there. Is it commonly used? A little bit. Zynga uses it, but not many others. And so there's not a lot of contributions going back. There's not a lot of people you can hire for it. There's not a lot of people who have information on it. There's no community, or at least not much of one. It's not robust to failure. One time when we pushed the magic button to start replicating all the nodes, it just stopped. And there's no hooks. There's nothing to push. Nobody has run into this before, so nobody's improved it. So we were sunk. It was over. What does it scale? It scales pretty well when it works. But the problem is when it doesn't work, you're sunk. But the whole system is designed to scale for you. So it actually does meet that need. Good debugging tools, I couldn't find any. And in fact, the logs themselves were bad. My favorite ever log message was, the error message was 0730AF is opaque. Okay, that's great. I'll just cry a little. So I actually ended up having a cheat sheet of all the messages that they would say and what I should do because they were not intuitive. And that's something that comes with maturity. You fix these damn error messages. And then is the cost justified? MBase was free, but without support. So if we wanted any support, we had to convert, and we just couldn't justify that. So we had to run it free, which meant that we needed to know how to use it. But it was a pretty immature product with no help. So it sank, and we got rid of it. So if I had a second chance to do this all over again, here's the things I would do differently, things I'm advising people to do with their startups. First is do logging on day one, meaning the moment your customers start coming in, have the logging ready to go, because logging will save you over and over again. And when I say logging, I mean everything that happens. Every GET request, every event, log how your systems are behaving and all of that. Send it all to Kafka and build a little system to extract it from Kafka and put it into S3. And just do it. You get a couple of things. You get basic analytics out of it. If you hook in StatsD, which I'd recommend doing now, you can get basic graphs out of that really fast. Go look up StatsD. You will be happy with that. You also can recover from data corruption, and your data will corrupt at some point. It did to us a lot. And when those days come, knowing that you have something logged where you can go in and get that user's object back and put it back into your main database is the best thing ever. So you also can do business analytics at some point. When you have enough people, you can put it in MapReduce, and then you can know anything about your site. Your site traffic starts to dip, you can start digging all you want and become a big data wizard. And I also would recommend having alerting on day one. This is another mistake we made. I didn't add Nagios until like the 4th month in, and I remember the day I did add it in, one of the founders came to me and was like, Marty, I can sleep now. He was getting up every hour to check the website every day. So things we could have done better. I think we should have sharded MySQL earlier. We waited until we were at our knees, and the problem is when you're at your knees, the whole site's on fire. So 3 engineers, the 3 of us, were dealing with the site on fire while trying to get the shard up and then moving all the data over. So, and the longer you wait, the more data you have. We had 1.5 billion follower rows to move over at the time. And that was most of the time spent just trying to shard was in data transfer. It took us 1 month to write the code and 4 months to actually do the transfer. I would try to avoid falling into the NoSQL trap that I've talked a little bit about, the magic thing where they solve all your problems. There are some good ones, and they are maturing fast, and I believe the technology is there, but I would look at them closely and answer these questions carefully for yourself. Do I need that technology, or can I exist on something that's a little bit more weathered? Then the other one, actually, this was This is one we fell across accidentally. We use a system called PyRes, which is a rescue implementation for Python, which is really simple. You put jobs into a queue, and this giant sea of nodes will take the job out and run it. It's really simple. There's other systems like Celery and RabbitMQ and all these others that we tried using, and they just didn't work out very well. And this system just worked. It worked so well that we've been using it as our background task processing system up until like a couple months ago. It worked really, really well. That took us a long way. I would also hire a operations engineer early, someone who can make your life better, set up Puppets, Chef, whatever. Make it so that you don't have to use Apollo 13 checklists, as I came to call them, because it's a giant list of all the things you need to do, and one of those things is going to stir the O2 canisters, and the whole thing is going to blow up. And also, I would recommend getting unit tests in earlier. That was another mistake we made, and it made development slower until we decided to bite the bullet and write unit tests for everything. A/B testing would also be really nice to have early on. A/B testing is the capability of trying version A or version B really easily. And we built systems so that you can use a system called Zookeeper or any system you have for configuration. And we have a dial. We have a system called the Decider. So you set up your A/B experiment, and it's on version A, and you can twiddle how many people see A versus B. So it helps with two things. It helps with ramping up a big product to everybody, because you can start with 5%, make sure it's OK, 10%, 30%, all the way up to 100%. And it's also good if you ever screw anything up, because if you try to push it out and you screw up, one button, the thing is off. You don't have to do any deploys or anything. So looking forward on Pinterest, things that I want to improve. We are continually trying to help pinners discover more things. One of our mottos is to put pinners first, meaning that everything we do, whether it's building new product or infrastructure or spam, line number one is to worry about how it affects the pinners. And one example I can point to is on the spam team, I could do something like, say, shut off the website and get rid of spam. That's going to violate rule number one of help the pinners. That's one of the more extreme examples. But it sounds kind of hokey to say put the customer first, but it actually does modify the way you think in just the right way. The other thing is better uptime and lower latency. We're always focusing on that. Faster development times. I want people to be able to develop products faster and twice as good and twice as fast. And that's one thing we focus on. We want to enable new products to go out the door faster. And the other one is reducing spam and abuse. And actually part of reducing spam and abuse is not to get rid of the spam necessarily, but to help products so they don't have to worry about spam. And that again points to putting the pinners first. It's not about fighting the spam. It's about making new things come out for pinners faster and better. And we also want to continually improve our collaboration. This is actually 180 employees is actually old. It's now around 360. And so we're getting to a size where we have to make sure that all of our communication is crisp, and we're really good at giving feedback. And one thing we could always improve is giving feedback. It's a very hard thing to get a big culture to do very, very well. So the third thing we learned is have fun. This thing can be very stressful. So if you're a founder and you've got a lot of employees, remember what they're going through and make sure that you help them have fun with it and not overstress. I've known people who have had nervous breakdowns in this industry, and it doesn't look pretty. And if you're an employee, I would recommend, if you're struggling, talk to your founder. And if they don't work for you, go talk to the board. Make this thing fun, because it's stressful enough. Yeah. So no, seriously, have fun. This thing's hard enough. Are there any questions? Oh, MySQL versus Postgres. So the question is about scalability or maturity of MySQL versus Postgres. I've actually found this to be more of a religious debate. In general, they work both very well. I know Instagram was like our sister company growing up. They give almost the exact same talk. It's kind of goofy. But they use Postgres. We use MySQL. They both work very, very well. So honestly, I think flip a coin. How much time do I have? Oh.
You said log everything.
Yeah.
What's your data volume like for logging everything that you touch?
I don't know. It's probably I'd have to get back to you on that, but I think it's damn near a terabyte a day or something. I'm not entirely sure. I have to look that up. But it's large, but it's worth it. So yeah, you'll sweat cost a little bit, but the day you need it, you'll be happy.
Was there another question here? Oh, here.
Where can we find this talk online?
Which talk? Oh, the talk I just gave?
Yeah,
so I've given a similar talk at a couple places. Look up Scaling Pinterest. you should be able to find this talk and a previous talk I did on that included sharding.
Okay, one more question. And what do you use to track your performance metrics for analytics?
How do I track my performance? So there's StatsD took us a long, long way. If you haven't used StatsD, I recommend go checking out right now. Etsy made it. You send a UDP packet with either a count or a timer, and then it includes a system called Graphite where you can show graphs and you can see how your SLAs are doing. The graphing system needs some work, but it took us a long way. We're now transitioning a little bit. We're starting to get more custom in-house to fit exactly what we need. I hope one day we'll be able to release some of those things. But we also use Ganglia, works really well for operations.
New Relics by any chance?
Use what?
New Relics by any chance?
Yeah, we use New Relic.
Okay.
Yeah, we used it a little bit. Yeah.
Okay.
We have time for a couple more questions if anyone has them.
Cool.
All right, well, thank you very much.
Is there one more question?
One, where? Here?
I just want to say it's a great speech that you gave. It was more, I'm a Pinterest user, and I just had a question if there was like a feature maybe in the future you could add.
I don't know. I can talk about spam features now. I'm really excited about them.
Okay.
I think right now we're focusing on massively improving guided search, which I think everybody knows about now. But if it's not on the web, it will be soon. I think it is on there now. But we're really excited about that, and we're excited. It's just the beginning of it. We put out the thing that works, and now we have to make it work really, really well. And hopefully we make people run for their money. I'm not sure what else. God.
What can I say? What it was, or
What's that?
could I just say what it was, or
Oh, what was?
like the idea for maybe a feature that you could add to Pinterest?
Oh, I'm sorry. I thought you were asking about new features.
No.
Oh, yes, please do. Yeah.
No.
Yeah. I'm sorry. I thought you were asking me to give up questions about what I could say about IP, and I was getting a little sweaty there.
No.
Yeah. Okay. Yeah, go ahead.
No, just basically because, for instance, the way that Pinterest is the boxes, right?
Mm-hmm.
But in the future, do you think maybe you could have like an actual pin board and people could like make it, like, the old school collages?
Yeah,
and then maybe have a printout?
I wanted to write a hackathon for that one day because someone showed me they did that manually by hand with Photoshop. They took all the pins and they made it like how people used to do with photographs, and you put it on a mirror with all the little. Yeah, I would love to play with that. That'd be fun. Maybe I should do that as the next hackathon.
I'd actually really like to hear about the spam features.
Oh, the spam features. Okay, so one nice thing about this talk is I can go and tell everybody about our experiences growing, and you can hopefully learn a lot about it and not make the same mistakes we made. The problem I found with spam is I want to do the same thing, but it's really hard. We've spent 2 years trying to get on top of spam, and we found that one of the hardest things to do is there's no good systems out there that are plug and play. There's a couple, but they don't work too well. So anybody who's running into spam, at the moment, the sad reality is that many of the big companies like Google and Facebook and us and Twitter have dedicated large teams who've been working on this for years. And so what's hard about that is many of those pieces are not yet readily consumable outside, but I want to make some of them like that. So one of the things we're building is from Kafka, everything funnels into a system we call Stingray. I think one of the big things that's happening right now, big data was sort of last year and the years before. The next big thing I think is stream processing, because everybody realizes they need to know big data now. And stream processing allows us to watch everything that happens on the site and make determinations fast, within seconds. Because with spam, if you ramp up an attack within a minute, we're already sunk. So I have to identify a new spam attack, make new rules about it, and turn around and delete it within minutes or seconds. And not only that, there's already stuff in the past that I have to get rid of that I didn't work on. So we're building out a system called Stingray, which sucks in everything, and one day we're going to start talking about it, but it's still very much in fast production. But it's to the point where now it watches everything. You can understand how what spam is coming in. You can turn around and write rules for it, and immediately all those rules start obliterating hundreds of thousands of spammers at once. And one weekend we deleted 2 million spam accounts with one rule. And then the next step after that is to build more and more features. The way to fight spam is you build lots of features. And what features are ways of detecting that you're a spammer. It's sort of like if you walk in and I observe your hair color and your face and your nose and what you're wearing and all these other things. The more I can do, the more I can say, oh, that person walked in, he's wearing a blue wig. He's a clown. Maybe that's what my detection model is. And I get rid of him. Now he comes in again. If he comes in and he's changed a little bit, he needs to change 40 things for him to get through the door before I know he's not a clown. And so if I can have a giant set of features, it's like walking through a landmine field, and you have to miss all 40 landmines. And that's the advantage we have. So we're building systems to build out more and more features, and then we're building machine models to take all those features and sort of say, that one looks good, and that one, and that one, and that one, and optimize the problem for us. So that's kind of the future of where we're going. The other big problems we're facing today are hijackings are big. It's not about making fake accounts. It's now getting accounts from database leaks. I'm actually going to talk about this tomorrow if you guys are interested. It's going to be my please store your passwords correctly talk, because most people are not. So tomorrow we're going to talk about this. The idea is that if you don't store them right and your database leaks, your database can now be used against everybody. So your password is now likely to be useful on Facebook and Twitter and everywhere else because everybody uses the same password everywhere.
I missed
Password
my
box.
joke.
What's
I'm
password
missing the
box?
joke. Yes,
Yeah.
or you can use password box.
Yes, I've heard more about this. Yeah, and if your password box, I sure hope you're using bcrypt. But yeah.
I know that the team's back there. They can answer that.
Okay, we'll talk
But
to you guys. Yeah.
Thank you very much, Marty.
Cool.
Really
Thanks, guys.
appreciate it.